Let's start with the new topic, that is conversion from SOP to POS. So SOP and POS are two methods of representing Boolean expressions. And the difference in between the two is that in SOP, the min terms are there which can be represented as sigma small m. Okay, these are the product terms in case of SOP. And we are taking 0 as a complemented and 1 as an uncomplemented form. Whereas in case of POS, we are taking max terms. Okay, we are taking how to represent those max terms in case of product of sum. Okay, and then we have already seen that what are the canonical forms of SOP and POS. Now in this video, we will see that how to convert from SOP to POS. So let's see what are the rules. Rule says that first of all, write down the binary equivalent of the min terms of SOP. We are taking that how we can convert SOP to POS means the very first rule is identify the min terms, write the value of min terms in binary format. Okay, then try to find out, identify those missing terms which are not in the SOP but in the list of possible combinations. I mean to say that, for example, you are having 3 variable function. 3 variable function means 2 to the power 3 equal to 8 possible combinations should be there. If 8 possible combinations are there and if out of 8, 3 are included in the SOP, rest of 5 will be considered as max term. And you will write those 5 max terms in form of POS. Okay. So rules are, first of all, write down min terms in binary, then identify which are not included in SOP, then write those missing terms, those missing values out of the list of possible combinations in term of POS. Let us see the example. The things will be more clear. Example is, for example, question is given f equal to ABC plus AB bar C bar plus ABC bar plus A bar BC. Any function is given. It may be f, it may be y, it may be x. Any function is given. Question is identify it is SOP or POS. SOP, convert in POS. If you see that it is POS, convert it to SOP. So let's understand the nature of the question first. Question is ABC plus AB bar C bar. Means here the product terms are there. Then we are summing up those product terms. Okay. So these are the product terms, and product terms are also known as the min term. Okay, so min terms are ABC, A, B bar, C bar, A, B, C bar and A bar, B, C. So 3 variables are there, A, B, C. If 3 variables are there, the possible combinations will be 2 to the power n, that is 2 to the power 3 equal to 8. Starting from 0 to 7. 0 to 7, these are the possible combinations of the 3 variables. Now let us see what are the values in this ABC, A bar, C bar, ABC bar and A bar, BC. It is 111, it is 100, it is 110, it is 011. Okay, so we are having 7, this is 7, okay, then it is 4, it is 6, it is 3. So 3, 4, 6, 7 are the min terms. So what we will do? We will cut this 3, 4, 6, 7 from the list of possible combinations. 3, 4, 6 and 7. Now we are left with 0, 1, 2 and 5. So these 3, 4, 6, 7 are the min terms. These are the min terms because it is our SOP. And the remaining terms, that is 0, 1, 2 and 5, these are the max terms. So 0, then it is 1, 2 and 5. Because we have to convert SOP to POS, so we require the remaining terms that we have identified, that is 0, 1, 2, 5. And these remaining terms are also known as max terms. Now using these max terms, we have to write a POS form. Okay, and POS is product of sum. Means we have to write the sum terms and then taking a product in between all the sum terms. So 0. 0 can be written as 000, 0, 0, 0. Why I am taking 3 zeros? Because 3 variables are there. Because it is POS, so 0 here stands for A. So it is A plus B plus C. So similarly, you can take this 001. Okay, 001 will be A plus B plus C bar. Okay, if I say 010, you can write A plus B bar plus C. 101 is A bar plus B plus C bar. So this is the case, means I am writing the max terms in case of POS. Okay, now because POS means product of sum, these are your sum terms. Now you have to take the AND gate in between all the sum terms. So it will be A plus B plus C dot A plus B plus C bar dot A plus B bar plus C dot A bar plus B plus C bar. So these are the functions that can be represented in POS. So what we did, we have identified whether the function given that is SOP or POS. Then if it is SOP, then extract the min terms, write the binary values, write down the possible combinations, cut down those min terms from the possible combinations, and remaining are your max terms. So this is the max terms. Here we are putting dot dot dot. These are the AND gates. So it is product of sum. So this is how we can convert SOP to the POS. Okay. So after converting SOP into POS, the next thing is POS to SOP. Okay. So this is all about the SOP to POS. I hope it is clear. For converting SOP to POS, extract min terms, then find out the balance terms that are the max terms and write down in form of POS. So this is the case. And SOP to POS is required in many cases where we want a reconfigurable computing to the another part of the computing. So how to convert POS to SOP? For converting POS to SOP, the rules are write the binary equivalent of all the product terms first of all. Just like in the case of SOP, we are extracting min terms. In this case, we will extract max terms. Okay. After extracting the max terms, write down the value in the binary format. Then write down the possible combination starting from 0 value, for example 3 variable, then 0 to 7, if 4 variable, then 0 to 15 and so on. Then keep cutting, that is in the max term. The remaining terms will be your min terms. Because destination says SOP, so it is min term. So min terms then represent in the form of SOP. Okay. So let us see with taking some example. Okay. Rule is very simple. Because POS is given, so you have to extract max term, write down in the value of binary format, and then convert to SOP by taking the balance terms. That will indicate the min terms. Okay. Now the case is that convert POS to SOP. Now see, this is given A plus B plus C dot A plus B bar plus C bar dot A plus B plus C bar dot A bar plus B plus C. So because first of all we will identify whether it is SOP or POS, because it is these are the sum terms and there are AND operation in between the sum terms, it means it is POS. The very first thing is clear. Now we are having POS, it means we should have max terms. So we will extract the max terms from this POS. So sum terms are known as max terms, so it is 0, 0, 0, 0, 1, 0, 1, 1, okay, and so on. Because it is in the form of POS, so the rules of POS will be followed. And the rule of POS says that if A is there, put 0. If A bar is there, put opposite 1, that is 1. So next thing that we will take care is the 3 variables are there. 3 variables again, it is having the possible combination starting from 0 to 7. 0, 1, 2, 3, 4, 5, 6 and 7. Now we have seen that 0, 3, 1 and 4. These are our max terms. So what we will do, we will just cut down 0, 1, 3 and 4 from the list of possible combinations of the values. Okay, because these are our max terms. So the remaining values, this 2, this 5, this 6 and these 7 are the min terms. Okay, so the min terms that we have identified from this is 2, then 5, then 6 and then 7. So next step is we will write 2 in form of binary, 5, 6 and 7, so on. Because 3 variables are there, so we will require 3 bits. So 2 can be written as 0, 1, 0. Because it is, we have to write down in form of SOP, so it becomes A bar, B, C bar. Okay, similarly, you will see that it is 101 or 110 or 111. Okay, so these are the min terms that we are getting out of the possible combination list by cutting down the max term values. Okay, so because we have to jot down this thing in form of SOP, so we are taking all the product terms individually and putting a plus sign in between each of these. Means or logical or operation in between these product terms. And the final function that you are getting is the desired SOP function we extract from this POS. Okay, this is how we are converting from SOP to POS or POS to SOP. Let's take one example to make it more clear. Okay, for example, I am taking a small question that f equal to AB plus A bar B. Because it is in the form of AB plus A bar B, means these are AB is product and we are taking the sum of this thing, it means it is a SOP. This is clear. Question is identify it is SOP or POS and then convert to the alternative form. Means if it is SOP, convert to POS. If it is POS, convert it to SOP. Now we know that it is SOP, so these individual terms AB and A bar B, these are the min terms. Okay, these are the min term. This AB and A bar B. Now we write down all the possible combinations first, because it involves two variables A and B. It means the possible values will be 2 to power 2 equal to 4. That is 0 to 3. Total 4 possible combinations are there starting from 0 till 3. So 0, 1, 2 and 3. Now what we are doing? We will find out the value of the min terms that are available with us in our question. It is 1, 1, 1 and it is 0, 1. So these are the min terms. 1, 1 means 3 and 0, 1 means 1. So the min terms that are available here are the 1, 3. Okay, so what we will do? We will cut these values from the list of possible combinations. These are the list of possible combinations and 1 and 3 are busy in min terms. So we are left with 0 and 2. Okay, so our max term will be 0, 2. Now we have to write down these 0 and 2 in form of binary and then we will take the POS. Because our destination is POS, so we have to write in form of POS. So max term is 0. Because two variables are involved, A, B. So we will write in 2 bits. 0 is 0, 0. Because it is, we have to write in form of POS, so it will become A plus B. Second is 2. 2 is 1, 0. So it will be A bar plus B. Okay, so we are writing the max terms in form of POS. At last, we are getting a function that will be f equal to A plus B, means this sum term dot the second sum term, that is A bar plus B. So this is the final answer that we are getting. F equal to A plus B into A bar plus B. This is your final answer. Means how we are converting from SOP to POS. Okay, again, question given was f equal to ab plus a bar b. It was SOP. These terms are known as minterm, and you can write the minterms in binary format by taking a bar as 0 and a as 1. Means if complement form is there, that is 0. If non-complemented form is there, that is 1. Okay, then write down all the minterms in the list, and side by side write down the possible combinations of the values. Because it is 2 variable, so 2 to power 2 will be 4. So 4 possible combinations are there, and 4 possible combinations are starting from 0 to 3. Okay, then we will find out which were our minterms. Our minterms were these 1 and 3. We have cut down 1 and 3 from the list, and the remaining terms are the max terms, that is 0 and 2. Now we have to write 0 and 2 in form of max term. We have to follow the rule of POS. And in POS they are saying that 0 means A and 1 means A bar. Opposite is happening over here in SOP in case of POS. Both are complementary in nature. In SOP 0 is A bar, 1 is A. In case of POS 0 is A and 1 is A bar. Okay. Then because you have to write in form of POS, so you will take this sum term and taking a product in between these two sum terms. So the final is POS. So the final value that you are getting, f equal to a plus b dot a bar plus b is the desired POS function. Okay, that we are getting from our SOP. So in this manner we are converting SOP to POS or POS to SOP. The key feature is if you are having SOP, it means that you have minterms. Okay, if you are having POS, it means that you are having max terms. So write down the possible combinations. Possible combinations can be found out just by taking 2 to power n, and n is the number of variables. If it is a 5 variable problem, then it will be 2 to power 5 equal to 32. And 32, out of these 32, you will cut down the values of minterm. Okay, and the remaining are the max term. If it is a question of SOP to POS. If it is a question of POS to SOP, then cut down the value that you are having, that are max terms, and remaining are the minterm. So in such a manner, you can write the values minterm, max term, canonical form, and as well as you can convert from POS to SOP and SOP to POS. With this, I am concluding my today's video. Okay, here we are seeing that how to convert any expression representation to another expression representation, means SOP to POS. So that's all about this video. We will see you later. Thank you so much.